Okay, our last video we took a look at the tangent function, and I think that's pretty difficult. And we're going to look now at secant, cosecant, and cotangent, and I think that's even more confusing. So in this age of technology, I am going more away from having students try to graph all of this and more answer the questions about the period and the phase shift and stuff. I mentioned that in another video. So I'm going to show you this, and I would limit it to some pretty basic questions about this. Here's what I think is fair game here. If you're graphing a secant function, then if this is true, secant is 1 over cosine, or cosine rather. Secant is 1 over cosine. Yeah, I said that right. If we were graphing this, here's what happens. If I graph a cosine function, so here's just the regular cosine function, secant is going to be its inverse, which is going to happen to be, it's literally going to be that you can draw asymptotes at everywhere that cosine equals 0. So I'm going through here, and anywhere cosine hits the midline, I'm going to draw an asymptote. And what happens then, secant is going to be whatever is a maximum of the cosine function, it then becomes the minimum of the secant, and vice versa. Do you notice how the bottoms of the cosine valleys have these u's coming off? The top of the cosine hills have these u's coming off. So I would go through here. Here's what you'll do. If you were to graph it, I don't know if I'd ask you to do that, but you're going to graph the cosine function, and then what you do, you draw the asymptotes. Anywhere that you hit the midline with a cosine function, you draw an asymptote, and then you create these u's. The bottom of the valleys, you got the u's upside down. The top of the hill, you got the u's the right side up. And that's how you create a secant function. Now, the same is going to be true for the cosecant function. It's 1 over sine. So I'm going to draw a sine function. Anywhere sine hits the midline, I'm going to draw the asymptotes, and then we're going to make those u's just like we did before. Now, the period of a cosecant and a secant function, they're based off sine and cosine, so they're going to have the same period. So this is asking us to graph it here, but what I would ask you to do, like on a test most likely, would be, I would be more concerned with, can you tell me all the period, amplitude, phase shift, and all of that stuff. Now, the amplitude here, because this is now going up, it isn't really an amplitude like it was before. So a cosine function, so secant is 1 over cosine, so a cosine function does this, right? Well, an amplitude is how high do we go, how low do we go. Well, this goes on forever. Secant functions then, if they're up here at the top, they don't really have a top or a bottom. They just stretch on forever. So this is now, they'll call this a stretching factor, but it's really the same concept. You would graph the cosine of this exact thing. So if you wanted to graph it, you would graph 2.5 cosine of 0.4x, and then just do the trick I showed you. Mark the asymptotes, make the u's. So what we called an amplitude now is going to be called a stretching factor for this. It's going to be called a stretch of 2.5. But how to find the period is going to be the same idea as it was. Nothing has changed. It's 2 pi divided by whatever is in front of the x. So we're going to divide 2 pi by 0.4. I have to think about what that would be. What is that going to make? Okay, so that would make it 5. I guess I should know that. So this turns a period, it's going to be 5 pi. Okay, so that's it. We don't have any shifts, vertical shifts or horizontal shifts. There's nothing in here. So I would just graph this cosine function then. If I wanted you to graph it, let's get to that. I would graph the cosine function. It would go right in here. That would be the cosine function. I'd fill in the asymptotes. Where does this function hit the midline? Hold on, I don't see. I don't think that's the same graph. Oh no, it would. It would be because it's compressed. So anyway, so we would graph this one. It's stretched out over 5, so it's got kind of a weird graph here. But wherever we hit the midline, which mine isn't quite perfect, we would draw those asymptotes. The bottoms of the valleys would give the u's, tops of the valleys give the u's. Okay, so same thing here. If I was looking, this isn't the amplitude anymore. It's now a stretching factor. This is turned upside down. and then we would have 0.4 to help us find the period. So the period would be 2 pi divided by 0.4 again, so 5 pi. So if we wanted secant, we're doing the cosine function. Is this the same question? Yeah, it's the same question, just turned upside down. So it's literally the same graph as the last one. We've just turned it upside down because of the negative in the front there. That's it. So we would take this graph and we would turn it upside down. That's it. Okay, so again, this gets harder. What I would ask, what I've moved to on tests, is I would ask you the stretching factor, the shift, and the period. I would ask you this stuff because it's hard to graph this. But so if you wanted to set this up, what you would do is just like we did before. You'd change it over. So I'm going to factor out that GCF here. And remember how we did that. The pi over 2 is going to get that pi over 3 pulled out of there. I'm pulling out of that in front of the x. I'm pulling it out like it's a GCF. And that is now going to turn into 3/2. Keep, change, flip. So my period here is going to be 3/2. Okay, so it isn't really an amplitude anymore. It's a stretch of 4. I have moved this all. We'll just call it a vertical shift. We've gone up 1 and a horizontal shift. This would be to the right. So, hold on. I screwed this up. So if I factored that out, this is -3/2. I was going too quickly. Okay, so I just set this up like this. This now is my horizontal shift. It's to the right 3/2, and I didn't do the period right. The period for a secant is 2 pi, but we're going to divide it by that b, which is pi over 3. So 2 pi divided by pi over 3. We keep, change, flip. It's going to be 6. Okay, so that turns out to be 6. Okay, now this gets so complicated that this is why I like this amount of information. But if you felt comfortable with this, what you would do is you would graph for cosine of all of this and then fill in the gaps. So let me get to it. So what we've got here that's not visible, that would be 4 cosine. So it would go, yeah, it's got a shift and everything, just so difficult. So, but this would be 4 cosine in here like this. It's got a phase shift, it's got everything. What I'm doing in class is I have this selected, like even with a cosine, you would pick something like this off the graph by multiple choice because they're so difficult. But this is cosine graphed in here. I would mark where it hits the midline, which mine doesn't do very well because I'm just sketching out really quick. And then I'd fill in the u's, and that's how you do the secant. So you literally just graph the cosine. Okay, so same thing. All this stuff, I'm just going to go through the pieces here. So it's not really an amplitude anymore. It's a stretch of 6. It's just like the amplitude used to be. It's also noticed that it's flipped upside down because it's got the minus in front. Now let's rearrange the formula so that we can understand all the horizontal shift. So I have factored out that what's in front of the x. I've factored out the 4, and I get x plus 1/2. Now, so distribute it back, and you'll see we'll get to where we were before. Send the 4 back through, we get to this. Now remember, I'm doing that so I can accurately read the horizontal shifts. Okay, so I'm stretched by 6. Find the period. It's 2 pi divided by that number in front there. In front of the x, it's the 4. This becomes pi over 2. Okay, how about, so a vertical stretch, or vertical shift. Sorry, I'm butchering all the language. Vertical shift is down 8 from this guy. And a horizontal shift would be here, left, because of the plus sign, left 1/2. Now, graphing this would be difficult, but I would graph the cosine function of all this if with all the, it'd be hard. But you graph all this, then fill in the gaps. I don't have a picture of that one, so I'm not going to do it. I wouldn't ask that. That's such a hard question. But okay, let's graph one period of this. Now, this is a little easier here. We're doing a cosecant, so we would graph sine, but it's still difficult here. There's a lot here. This would now be the stretch. It'd be called 3. It'd be flipped upside down because of the negative. We find the period. Period is going to be 2 pi divided by that number in front of x, and so our period is going to be pi over 2. So I don't know if I have this here. I'm going to jump ahead. I would be graphing negative 3 sine of 4x, and then I would fill in the spaces. Let's see if we've got it here. So in this space here is negative 3 sine. So sine normally starts at 0 and goes up. Well, because it's negative, it's going to go down and then back up. And now we have the whole cycle has to be finished. What was our period? Our period was pi over 2. So the whole thing has to be finished by the time we get to pi over 2. Now, anywhere we hit the midline, we drop the asymptotes, we put the u's in, and we got it. Okay, here's another one here. One period of this, we're just going to go through. We got a stretch of 0.5. This would be based off a sine function. To find the period, it would be 2 pi divided by that 2 in front of there, so the period is pi. So what I would do here is I would draw a sine function that has an amplitude of 0.5 and has to finish within one cycle of pi. There it is. Now, I would, and mine is not very accurate again, but I would put in the asymptotes. Anywhere that the graph hits the midline, I'm putting in the asymptotes, put in the u's, and you got it. Okay, they just want secant and cosecant. This really complicated cosine would be graphed here. Well, if I want that very complicated secant, all I have to do is anywhere. Now the midline here is 1 because it's been shifted up. So I got a midline running through here. So anywhere where I hit that midline, which is very difficult to see, anywhere I hit that midline, I'm going to drop an asymptote. And then I'll put in the u's. So again, very difficult, but I hope that makes sense. The only thing that changed here is we shifted up. So I've got to mark my midline as if it's moved up. Now, anywhere I hit the midline, I put those asymptotes, fill in the u's, and that's how they got this picture here. Okay, cotangent is really crazy as well. We're going to do a tangent function, which was hard as well, and we're going to flip it around. So it's going to flip, because cosine and sine flip, what happens is a cotangent is going to flip horizontally. Let me show you what this means. So I would do, if I want to graph this, I would be doing 3 tangent of 4x. Again, very complicated. I would ask more about, do you understand the pieces here? So let's go through the pieces. I guess we saw this with tangent too. It's not really an amplitude. We're going to call it a stretching factor because it doesn't have a peak or a valley. It goes on forever. Now, remember the period of a tangent function is pi. So if we're taking pi divided by this b in front of the x here, it's pi over 4 would be our period. Now, we'd sketch this graph. Remember our trick in that tangent video. Again, I'm not focused much on the graphing on these. I just want you to see how it's gone through. I'm more focused on can you decipher the stuff, but let's do a couple of these. So the trick for tangent was if I can make everything in there become pi over 4, at pi over 4 tangent all turns into 1. So I can get a couple of points to graph this by turning all of this into pi over 4 and making some clever selections. Do you see if I choose pi over 16, this all to go in for x, this all becomes 1. This whole thing becomes 1. So 3 times 1. This gets me a point to help me get an accurate graph. Now, if I do this again, look, they chose 3 pi over 16 because that will come in to turn out to be 3 pi over 4, which is another location where tangent equals negative 1. So this is one cycle away. Hold on, I'm thinking about that. Yeah, how are they getting -1? Hold on a second. Yeah, okay, that's a half a cycle away. Okay, so what they've done here is to make something symmetrical here. By choosing a half a cycle, there, so remember the period here is pi over 4, so they've chose half a period in order to get us a version with the negative. So they made this turn into -1 by choosing 3 pi over 16. So remember the tangent is positive at pi over 4. It's negative at negative pi over 4, or you could flip it around several different ways. Now, I'm not going to focus much on getting these precise points again, but just to see, they chose a clever one so that we could get -1 out of tangent. 3 times -1 gets us the -3. Okay, now let me show you how we're going to draw this, or how it should be drawn. So in here in blue is this tangent function. Okay, we've got our key points, which we didn't really need. So if I'm drawing this tangent function, I've got my asymptotes here. So this is what the tangent function had done from our last video. What we did is we saw anywhere that cosine would be 0 gets an asymptote. Then we drew in our blue line with those there. And again, we could have had those accurate points from right here. Now here's what cotangent will do. All right, anywhere that a tangent function hit the midline, because we're turning this upside down, anywhere where tangent hit the midline is now going to get an asymptote. Okay, so tangent hits the midline right there and gets an asymptote. Tangent hits the midline there, we get an asymptote. Now, here's the best way I can wrap my head around how to make this graph. We are now going to, in each of the quadrants we have done, look at the quadrants we've created. There's the tangent asymptotes, there's the cotangent asymptotes. In each of those quadrants, what you're going to do is you're going to flip the tangent right to left. So here's the tangent. I'm going to flip it right to left. You see that would then make this. In this quadrant, I'm going to flip the tangent right to left. It would then make this. And this quadrant that we've made, we're going to flip the tangent right to left. It makes this. And in this quadrant, we'll flip it right to left and make that. So very difficult. I think tangents alone are very difficult to do, but what we've done, anywhere tangent would hit the midline, we're going to draw in an asymptote. Okay, now, in each of the quadrants that have been created between the tangent asymptotes and cotangent asymptotes, we're going to flip tangent's graph around. Flip it around, flip it around, flip it around, and that's how we made the green line. Okay, so a question like this, what I'd be more concerned about because of the difficulty of all of this would be, can you tell me the right pieces? So I'm going to put it in the correct form where our shift is accurate. We're factoring out that pi over 8. So pi over 2 right here is getting divided by pi over 8. So pi over 2 times 8 over pi. This is going to get me a 4. Okay, now I'm ready to read it. This is a stretch of 4. Our period is going to be pi divided by that pi over 8. It's going to give me 8. I'm not going to write all this out. I've got a shift to the right of 4. I've got a horizontal shift to the right of 4. I've got a shift down of 2. So very difficult. That's what I would take on something this complicated. Maybe I'd ask you to identify it by multiple choice graphs. But if you wanted to then graph this yourself, you would do this graph with tangent. Let me see if they even did it. Yeah, they didn't even do that. You would do this with tangent, and then you would do that trick I saw wherever tangent fits in. They didn't even do it. So a question this hard, I just would want you to know, can you identify the pieces? Okay, now they end with an application question. I read through this. It didn't make much sense to me, and I'm not going to ask it of you, so I'm going to end right there. So again, tangent, so we're doing secant, cosecant, and cotangent. Very difficult, but what we do is we base them on the graphs of sine, cosine, and tangent, and we basically invert them to help us graph these.